Okay, should have been about 12 minutes. Let's continue with our exponent work. So these ones are different, right? It's different than the ones on the last couple pages. But also related. They've got exponents. Let's talk about what's happening. Let's walk through one more together. Let's talk about this one down here with the variables in them. So x squared to the 6th. So this is weird, right? It's like x squared is going to be multiplied, can I fit it? By itself, I guess you don't need the dots in there, huh? 6 times 1, 2, 3, 4, 5. Oh, 6 times 1, 2, 3, 4, 5, 6. X squared 6 times. But then, like, how many x's are in each of those little parentheses? 2, right? So really, how many x's are being multiplied all together? Well, 2, 4, 6, 8, 10, 12. And how do you get 12 from 2 and 6? Well, if you do x to the 2 times 6, that'd be x to the 12th. x12. So how do you do that with just variables? Like no numbers at all? Well, just like we did right here. A, whatever number that is, to the exponent of n times m. Right? Whatever that is, that's the exponent. Now, key question. Does that rule work for 2 to the x to the 4th power? Yeah, it does. You just multiply these exponents. 2 to the 4x. That's kind of cool, right? I don't know what this x is, but we can say, well, 2 to the 4x. Okay. Let's keep going. You should have tried this one too. Oh my gosh, this is like this is one of the most exciting things to do in math is when you get to do stuff like this, like, cross stuff out. Like, that's the best, right? Let's hop down again to this one with variables. So, yeah, it's a fraction, but how many x's are on the top in the numerator of that fraction? 10 of them, right? 10 x's being multiplied. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? There's 10. How many on the bottom? Well, 5. 5 x's in the denominator. 1, 2, 3, 4, 5. Okay, now since we have the same thing top and bottom, and all of this is being multiplied, right? These are all being just multiplied. You can cancel them out. This is where it gets exciting. Cancel them out. How many x's are left? These ones right here. I'm counting 5, right? We crossed out, there was 10 on top. We crossed out 5 of them. So how many are left? Well, there's 5 x's being multiplied together. That would be x to the 5th. Now, how do you get that without having to write everything out? Like, what if it was x to the 700 over x to the 2? Like, I don't want to write out 700 x's. Use the pattern that you noticed, right? Down here on the bottom. A to the m over a to the n. You can just subtract m minus n, right? Like we did here. 10 minus 5. Or 2 minus that sneaky 1 there. 5 to the 1st. 6 minus 3. 6 to the 6 minus 3 would be 6 to the 3rd. Okay. Now, does this rule work for 4 squared over 4 squared? Well, that's kind of weird, right? What happens when you have the same thing over the same thing, right? 4 squared is 4 times 4, that's 16. 16 over 16, well, that's just 1. So that's also equal to 1. We're going to leave this one kind of hanging out for a second. Well, we might come back to that another day. All right. Flip to that last page. These ones are pretty short. The last one especially is pretty cool. So take about the next 10 minutes. So look at the clock. Substitute teacher or someone on the board, can you write down the time it'll be in 10 minutes? We'll come back in 10 minutes. Go. Okay, it's been 10 minutes. Let's keep going. This second to last section, I'm seeing fractions again, but like different than this one, the bottom doesn't really have an exponent on it. It's just floating out here outside. Well, remember what exponents do. It means you multiply something by itself that many times. So that would be 5/6 over 5/6 over 5/6 over 5/6. There we go. All right. Now, what's cool with multiplying fractions is you don't need a common denominator, right? Hopefully we remember that. You can just multiply straight across. Multiply the numerators, multiply the denominators. But this is going to be a big number. I want to keep it simplified. And plus, we're dealing with exponents. So let's write it with exponents. How many 5s are being multiplied in the numerator on the top? 4 of them. 5 to the 4th. And what about the bottom? How many 6s are being multiplied? Also 4. 6 to the 4th. Bam. Done. So, hopping down to this last example, we don't need to write it all out. Let's use our logic. Skip ahead. X to the 7th over y to the 7th. It's kind of like it got distributed. That exponent got distributed to the numerator and denominator. So this last one, this mathematical definition one with just variables, well, the exponent is m. So a to the m over b to the m. Now what about this? Let's use that rule. 5 to the 3rd over 0 to the 3rd? Well, what is 0 times itself 3 times? 0 times 0 times 0. That's going to be, I think 5 to the 3rd is 125. 125 divided by 0. Does that even work? Like, when we pause our video next time, you might check it and see if that even gets an answer. We'll come back to that another day. All right. Last section. You guys doing great. This is where it gets cool. We saw a question like this up above, but there's a little tricky little rule here. Remember, same thing over the same thing. This is just a big ugly 1, right? It reduces down to 1. Kind of like this one also. Big ugly 1. But if you write it out longhand, x, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and you, right, they could all cancel out and you get 1. Great. But remember the other rule we looked at before when you had a fraction and you could subtract? You could subtract them? What if we use that, right? X to the 6th minus 6. That's x to the 0, right? That's equal to x to the 0. So if these are both the same thing, what does that mean x to the 0 has to be? 1. And actually, anything to the 0 is 1. This little section here gives you the reasoning behind it. I don't want to just tell you to memorize something without giving you a chance to understand why it works. This explains, and hopefully if you thought through it and were listening, why it works. But we're going to want to remember this. Anything to the 0 is 1. But what about 0 to the 0? Down here? Save that for later. We're going to come back to that. That's a tricky one. But anything to the 0 is 1. Okay. Now, you may put this in your binder. Notice I put up here day 2-6. You may put that in your binder in the appropriate spot. Substitute teacher. Substitute. Will you please hand out these 2 sheets? And guys, these should go in your notebooks also. Check out mine. My binder's all set up just like yours. Oh! Should go in like this. And notice I got up here. Again, oh, don't close on me. 2, 6, 2, 6. All right? So hand out these papers. Put them in your binders. We'll come back with our last video. We're going to summarize some stuff. And then you got time to work, okay? Get to it.